That's right. Thank you. Thank you for having me here, and thank you all for taking the time to listen to me. Basically, I'm just going to present a success case that I've had with HTCondor. We've had a lot of them here since we've used HTCondor, but this is our most recent, and I think probably one of our best, just because multiple universities were involved, and we came together and solved the problem that they had. So. Yeah, I work for Clemson University and a Center for Geospatial Technologies, and I work in the GIS department. And for those that don't know what GIS is, oh, did I share my screen? I'm sorry, I need to share my screen. Hang on one second. I apologize. There we go. Okay, there's the title screen. And then everybody can see that, I hope. So what is GIS? We want to talk about that. So GIS, for those that don't know, is basically just taking geographic data and correlating with other types of data. So it can be any type of data. There's so many types of data. You can use economic, social, political, environmental. There's just all this data, and you correlate it to geography, geographic locations, and you can get a whole analyze and get a whole bunch of different analysis from that kind of thing. So GIS, it's kind of under the scene. Not many people know about it. You know, every time somebody asks what I do and I say GIS programmer, they say, what is that? So it's not really well known in circles, but it is huge. It's ubiquitous pretty much everywhere. So, and, you know, worldwide, Esri has a user conference. Esri is the main software provider for a lot of GIS commercial software, and they have a user conference, and every year it's close to 20,000 people that attend that in San Diego. So it's pretty big, and it's well known in the GIS circles, but a lot of people outside of GIS don't know about it. So basically, Esri, as I said, is the kind of the leader of the GIS commercial platform. And fortunately for a lot of universities, including Clemson University, we have a campus site license that they give us, which allows us to have unlimited access to a lot of their products or software products. It's huge because otherwise it costs quite a bit. So they're pretty good with being helping universities work with GIS software, so that we can teach students and faculty and all that kind of thing how to use it. And then, of course, if you look here, there's different types. They have servers, desktop applications, mobile applications, online applications. They have a whole online repository stuff. So it's pretty big. Their platform is pretty large and big footprint. And as far as desktop software, Esri provides a thing called ArcGIS Pro, and it's basically a Windows solution only. So you have to have Windows or some kind of virtual machine to run Windows in order to run ArcGIS Pro. And so this is one of the reasons we use HTCondor, because this software is not convenient to port to like an HPC system or HTC, with a Linux base. So we have Windows platform, and this is on there. So we need a solution that helps with Windows, and HTCondor fits that really well. So part of the installation for ArcGIS Pro, there's a Python library, and it's licensed, and it's called ArcPy. And what this does is basically has a lot of geospatial functions that go with it. So there's a lot of stuff you can do with this, and it's licensed, so you have to install ArcGIS Pro in order to be able to use this license. And again, now ArcGIS Pro is on Windows, so it's kind of hard to use ArcPy outside of Windows. And again, it contains a lot of geospatial processing functions that are very useful. A lot of them are processing intensive, so a lot of them can take a long time to do what they have to do based on the data set that you're using. So the story starts, that's where our story starts, is Yale came to us and they had a problem. They wanted to create what was called an origin destination cost matrix between census block groups and bank branches. And if this is just a little sample of the picture there, you see the purple lines, that's like 6 points that they're doing. And basically what it is routing. It's taking a routing for each point from each origin to each destination, and calculating a cost matrix for it. So is it less driving time, the least amount of driving time, the least amount of distance, and other things like that. So Yale came to us and they had a big data set. As an example, just as a visualization example, this is 177 by 177 OD cost matrix. This comes to, so each, for each origin, it has to go to each destination. So if you multiply that, that together, it's 31,329 total routes that are calculated. And so you can imagine that as these get bigger, these origin destination matrices get bigger, the processing time goes up. So our challenge was Yale had 215,754 Census Bureau groups as origins, and they wanted to create an OD cost matrix with 51,000 bank branch destinations. This comes out to about 11 billion total routes that need to be calculated and they wanted the least amount of driving time. So you can see here the census groups, it's blue, and then the bank branch destinations are in the green. So you can see that it can get quite, there's going to be a lot of computation for this matrix. So what our solution is, of course, is to use HTCondor. And we have our GIS lab in our library. We have about 34 Windows 10 PCs. They each have 8 cores and 32 gigabytes of memory, and they all have ArcGIS Pro installed. So they all have access to the ArcPy library and, of course, the Condor scheduler. So what we had to do first, of course, the 3 main things for schedule processing, we prepared the data. They gave us CSV files, Yale did. So we took the 2 CSV files, the bank branches, and geolocated them. Basically, we put them on points on a map. So you saw the thing here. This is geolocating, where we took the locations that were in the CSV and we put them on a map so that you can see, kind of get an idea where they are visually. And then we took all the bank branches and we split them up into 51,000 entry tables. So each bank branch table, there was 51, they had 1,000 entries. And then we split these CBG locations into 22 10,000 entry tables. So we were going to do each OD cost matrix processing run, job run, was going to be 1,000 by 10,000. This comes about roughly to 1,122 jobs that we had to submit. And of course we did that, and it wasn't too bad. I come from a mainframe background, so job schedulers are not too unfamiliar to me. So that really helps when I started learning Condor. It was awesome. And so yeah, I kind of took to Condor like, oh, this is amazing, how well it works as far as the scheduling and stuff goes. So we were running approximately about 180 jobs concurrently as we were doing this. And each job took probably about 25 to 35 minutes to complete. And then, of course, after the job was done, it returned a table, basically, of that process data. And there was 122 tables, or 1,122 tables that were returned to us. Then we copied these back into CSV files, these tables back into CSV files. So there's 1,122 CSV files out there. We didn't merge them because 11 billion as one CSV file is that's just too big, and you really can't do anything with it. So we just kept them split up as CSV files, but all that data is in there. The thing with the OD cost matrix, you could graph it out visually, but something like that, it's not really necessary. It's just a straight line from one origin to one destination. So we didn't have to actually graph or visualize anything. It was just the cost estimate of driving time for each of those points. So basically, after all was said and done, we all ran the 1,122 successful jobs ran. And we created the tables, the OD cost matrix tables. The total processing time for all of that was probably about 5 hours. and that's just processing time. And then the total time it took to start to finish, it was about 2 weeks. And this is because there was an issue. And this is one of the things with Esri, and they have this licensed ArcGIS library. They have to validate the license every time someone tries to import it. So they have to make sure that you are a valid user, you have license you paid for, and all that kind of stuff. And when I was trying to submit these jobs, I was getting an invalid license for some of them. So what would happen is I would submit like 20 jobs, and then 8 on one PC, because there's 8 cores, would be submitted, but only 3 of those would be successful, and then the other 5 would fail. So, and with this invalid license issue. So I looked at it and I tried figuring it out, and finally we figured it's some kind of resource conflict, and it hasn't actually been resolved yet, but I came up with a workaround to fix it. So we were able to run the jobs all successfully, successfully. And then we were at that point, I called Esri up and told him, hey, this is, the situation. The good news is Esri was very interested in what we did, so they're actually looking at ways to fix that problem and allow us to hopefully in the future not have to do the workaround. The workaround was I basically did a try except clause for the import. If the import worked, then I let it go. If it failed, I waited a second and then tried it again. So that's how I got past that. So that's what makes me think it's some kind of conflict with their server license when multiple attempts to import the library occur. And that was really the only hard issue that we did. I mean, that we had to get with Wisconsin. They were awesome. They helped us, because I was scratching my head to get through this and trying to figure it out. And we were kind of under time constraint because Yale, they wanted to, kind of get it as soon as possible. And, we didn't want to look bad. So, so we tried to get this up as soon, as quick as we could. And all time, it took about 2 weeks to get everything done, including downloading all the CSV files to a cloud storage that they could use to, they could pick up the files from. Esri, Yale went to Esri first before they came to us with this, and they said, Yale said, we have this problem. We need to do this large calculation, and Esri didn't really know how to handle it. So they said that function's not really compatible with multi-processing. We don't really know of any other way to get that to to do it quicker than what you want. And so then Yale came to us, their GIS department, and asked us about, because I think they had heard that we were using HTCondor, and they came to us and we talked to them. Yes, we've done this before, and we showed them some examples, and then we did it. And so we gave back, and I think they were extremely happy about that. So one thing also is, I mentioned the Esri user conference every year. They're going to have one this year coming in July, and I probably plan to talk about this then too. So that's going to be 18 to 20,000 users that are going to, well, I mean, not all of them will listen, but I hope to get some ears, especially with Esri, so that maybe they can work a little more to provide support with HTCondor and the Windows license for ArcGIS Pro. And that's about it. I think that's everything. Please feel free to ask questions, and thank you very much. I appreciate it.